Hello, 8th graders. We are back at it again this week, and we are going to do the Solving Systems of Equations Graphing Part 2. So last week we did these notes together, and then you guys should have completed the graphing homework. If you jumped on the Zoom meeting with me, I think we did one of these together. But today we're going to start off by doing the part 2. So why this is a little bit different, or why we have a part 2, is because sometimes the system is not always in slope-intercept form, and before we can graph it quickly, we like to get it in that form. Not to say that you couldn't use one of our other methods. Like if I looked at the first equation, I could use the cover-up method and get my 2 points, my 2 intercepts, and then graph it. But my second one, that really wouldn't work. So I would rather just take both of them and get the y alone, and then put that in slope-intercept form. So I would move the x to the other side. Don't forget to bring down the negative. Then divide by the -2. Make sure you divide everything by the negative. So I get y equals, if there's nothing with the x, there is a 1 there. A negative divided by negative is a positive, so this turns into positive 1/2 x plus 4. Okay, and then if I did this with my other equation, I have 5x plus 4y equals -12. And if I move the 5x over first, I get 4y equals -5x minus 12. Then if I divide everything by the 4, and remember that slope, we can just leave it as a fraction. We actually like that. 12 divided by 4 is 3. So now I'm going to graph both my lines. My first one starts at +4. 1, 2, 3, 4. And it's a positive 1/2, so up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2. And then my other one starts at -3. And then I can't really go down 5, so I'm going to go up 5. 1, 2, 3, 4, 5. But I have to make my negative the 4 then. 1, 2, 3, 4. And you can see right then where they cross. So, draw my 2 lines. I need to get my ruler. And there's my other one. So the point that they cross is 1, 2, 3, 4, -4 on the x, and +2 on the y. To check this, you can put those in for the x and y in both equations. So this turns into -4 minus 4. Does it equal -8? Yes. Okay, and then check this one. Again, the 5x, so it's 5 times -4 plus 4 times 2. This gives me -20 plus 8. -20 plus 8, -12 equals -12. So that one's right. So that's how we check our solution. Okay, so now we're just going to practice solving a few more by graphing. If they don't give it to us in slope-intercept form, we're going to get it there. So this first one, x minus y equals 1. What I'm going to do is move the x over by subtraction. I actually want to move the y over, but I'll just do it this way for now. And then I would divide by a -1. So this turns out to be y equals x minus 1. So if I go to graph that, start at -1, your slope's a positive 1. Okay, and then my other one is just x equals 3. So remember that means that it crosses the x-axis at +3 and it's vertical. It just goes straight up and down. So where's the point of intersection? The solution is right here. So it's 1, 2, 3 for your x coordinates and 2 for your y coordinates. Okay, our next one on this page. Again, I have 7x minus 2y equals -8. So I'm going to move the 7 to the other side. -2y equals -7x minus 8. Then I'm going to divide everything by a -2. Y equals +7/2 x plus 4. So I'm going to start at +4. 1, 2, 3, 4. I cannot go up 7, so this is the case where I have to go down 7. 1, 2, 3, 4, 5, 6, 7. But then I have to go -2. My slope is positive, so I'm going to make sure I have that. And then my other line is y equals -3. So that means that -3 is going to go straight at a horizontal line at -3. So where does it cross? Well, right here at -2, -3. So these are kind of highlighting some of those special cases. Even if they are that straight vertical or horizontal line, they still have a solution. So the next two, you guys are going to be able to pick out some of those special cases perhaps. So for the first one here, if you are looking at it and look at how much stuff matches up, what do you think is going to happen? I'll let you guys just think. Do you think it's going to be a no solution? Do you think it's going to be an infinite many solutions? Or just a one solution like the ones we just got done graphing? I'll let you guys think about that for a second. I am going to solve both of them for y. Now, you're going to get to the point where you probably don't have to do this, but I'm going to show you for our example today. Move the 2x over. So I've got 3y equals -2x minus 12. Divide by 3. Got y equals -2/3 x minus 4. Then I'm going to do the same thing on the other side. Move the 2x over. 3y equals -2x plus 3. Divide by 3. Y equals -2/3 x plus 1. Okay, so when you guys look at these, what's going to happen? They have the same slope, which means they are, I hope you guys said parallel, because that's right. I'm going to graph them to show you. Starts at -4, 1, 2, 3, 4, down 2 over 3, up 2 over 3. So there are a couple ways to kind of approach these. You guys are going to get good at looking at equations. Down 2 over 3. And if you need to, you can use that graph to check. So they are parallel, so this is a no solution. You also will see it like that. Okay, so now, what do you think is going to happen? I mean, if they are the same from the start, are they going to change at all when we get y by itself? No, they're the same equation. So if they're the same equation, that means they are the same line. So that means infinitely many solutions. I hope that you guys can see that I don't have to take it any further. So what we're hoping is that now that you have some examples to look at, we can just look at the equations in standard form. We don't have to get y by itself. We can predict if it's going to have one solution, no solution, or infinitely many solutions just by looking at the equations. So there's a couple of things to look at. If the equations are the same, like the first part of it is the same, but the numbers are different at the end, it's going to be like our first example. They're going to be parallel, so it's going to be a no solution. What happens is when we solve for y, the slopes end up exactly the same, okay? And you guys can kind of picture this. So these are parallel, same slope. Okay, so again, and if you look and they have the same exact equation, just like in our last example, do you really have to get y by itself? No, the same exact equation means that they are the same line. So if they're the same line, that means that we have infinitely many solutions because they share every single point. Okay, so I'm going to jump up to this example right here. Now this example, if you look at it, they are different equations. Okay, the next thing you want to look at is, could one of them be divided, every term be divided by the same factor? And for example, in this one, 2, 7, and 14, they do not have a factor that they all can be divided by. So if you can't simplify it, they aren't the same line, you're not going to get the same slope, you can reason that it's only going to be one solution. Okay. And that's the same thing with the next one. You can't simplify it. They don't have the same x and y coefficients. They don't have all the same answers. So we know this one's going to be a one solution. And what I mean by simplify, I'm going to kind of make evident in these next few. So in this one, I can't divide the top equation by anything, but if I factor out a 2, it's called factoring out. We really haven't done a ton of it, but if I divide this whole thing by 2, I get a 1x minus 3y equals 12 divided by 2 is 6. So do you notice that this and this now match? So now that they match, this is an infinitely many solutions problem. Okay, the same thing with the next one. Notice 12, 4, and 8. They can all be divided by 2, but they can all be divided by 4. So I could take 12 divided by 4 is 3. So I'm going to show this. Divided by 4. 3x minus 1y equals 8 divided by 4 is 2. Now, notice that these are matching, but these are different. Okay, so what happens when your x and y match, but the numbers are different? This means that they are parallel, and this is going to be a no solution. Okay, why don't you guys pause it and see if you can simplify the next two just before I do them with you. Okay, so hopefully you guys did them on your own, and now we're going to do them together. If you would take these and you would try to simplify, that's what you're looking for. The top equation is obviously smaller, so I'm going to look at the bottom equation. What can go into 15, 6, and 72? Well, I know that 3 can. So if I divide 15 by 3, I get 5. And if I divide 6 by 3, I get 2. And if I divide 72 by 3, I get 24. So again, the x and the y's match. These are different, which means that they are parallel. They're not the same line, but they are parallel lines, which means this is a no solution. Okay, last one. 14, 21, and 35 can all be divided by 7. So if I would take and divide all of them by 7, I would get a 2x plus 3y equals 35 divided by 7 is 5. So these end up being, these end up being the same line, which means infinitely many solutions. Okay, so our last problem, it says, let's solve the word problem below by creating and graphing a system of equations. So this means that we're going to have to come up with our own equation. And it says, Sarah plays basketball. In her last game, she scored 24 points from 2-pointers and 3-pointers. She made a total of 10 baskets. How many 2-pointers and how many 3-pointers did she make? Let x represent the number of 2-pointers and y represent the number of 3-pointers. Okay, so first off, we don't know how many baskets of each, but she did score 10 baskets. So when I like to think about this, I'm like, okay, 2-pointers plus 3-pointers means she made 10 baskets. Okay, then let's put some points with this. So each 2-pointer obviously is worth 2, and each 3-pointer is worth 3 because she had a total of 24 points. So when we put these two systems together, it finds out the possible number of 2-pointers and the possible number of 3-pointers that she made. It's very common for equations to either be in slope-intercept form or in standard form. But like I said, what we were doing earlier, to get them in graphing form, we kind of like to put them in slope-intercept. So I'm going to move the x over, and I have y equals negative x plus 10. And then I can do the other one, 2x plus 3y equals 24. Move that 2x over, 3y equals negative 2x plus 24. Divide by 3. Y equals negative 2/3 x plus 8. So I am going to graph now. Make sure your graph, these ones go by ones, but they are just the positive coordinate because we were dealing with baskets and points. So if I start the first one, I'm going to start at positive 10, and my slope is a negative 1, so it's just going to go down like that. Okay, and then my other one starts at positive 8, and it goes down 2 and over 3, down 2 over 3, down 2 over 3, down 2 over 3. Did I do something wrong there? Down 2 over 3. Oh, I did over 2. There, that explains. So I was like, shouldn't have 2 points. So ignore that little dot there. It just was a goof on my end. So the point of intersection was 6. So that's my x. And my y was 4. So the final answer would be 6 2-pointers and 4 3-pointers because she scored 6 2-pointers and 4 3-pointers. Okay, so what you guys are going to do for your homework is the graphing part 2 homework. And then you guys can see how it just goes these 2 pages. Okay, these ones you should be able to predict without having to graph. And then this is what we will do on Friday. So I hope you guys are doing great. Make sure that if you have questions, you let me know. You can take a picture, you can send it my way. These ones are all numbered, so it's easy. And I might be able to have some Zoom time with you too. So we'll talk to you soon.